To begin with, Mr. Baldev, I would like to start with you. What are the impacts of grid integration technologies like HVDC, transmission, and power electronics on energy infrastructure, efficiency, and resilience?
Actually, because as we go more and more into RE penetration, the transmission has to be developed to take care of this additional generation. And HVDC being the, you can say, major contributor for transmission, and it will definitely have a major role to play. And we have to upgrade our capabilities in HVDC. And this is not a thing which can be questioned or disputed, or I don't think there is anything on that. The other thing is about the power electronics, because power electronics is now, they are in every sphere of whether it is a utility or whether it is a consumption or it is a generation, transmission, everywhere it is there. Even in HVDC, we have a lot of power electronics. So this is going to play a major role, even in the loads also. The major impact of power electronics is coming in the loads itself. What is happening today is that earlier the conventional loads were inductive loads. Now today, if you see that these companies, communication companies like Jio and all, we had a problem. Jio Nagpur's installation, they complained that their power factor is always leading because their load is only, they don't have any conventional load. All load is a leading load only. Mostly the things are set up at 0.95, 99 and all power factor. These devices which they use, the power electronics devices, UPS systems and all. And again, they are connected to the grid at a very large distance, sometimes 10 kilometer, 20 kilometer and all. That line impedance, the capacitance is very high. They are always into a very leading load condition. And it is a challenge to sort of work there. So this imbalance which will be created due to the load pattern also is going to be taken into account. So this is something which I could recollect because of your this question about HVDC and the power electronics coming into the picture.
Thank you so much for explaining, Mr. Baldev. Mr. Vikram, what are your observations on the same?
So let's start from the large-scale renewable power, which we have so successfully been able to integrate into our grid at a very less time interval. This would have not been possible if our grid was not so strong. Yeah. So luckily, our planners, they took the right decisions to make a good national grid. We had a unified grid in time. We are able to have five strong regions which are controlled very well by Grid India now, called POSOCO. Imagine if this was not there. So we would not have been in a position to integrate even this large-scale solar power or wind power which is there. And while this was made, a very large interregional transfer capability was possible with the HVDC lines which were built. Whether it was north-south or east-south or such long lines. India is a very large country and we need the HVDC lines and we built them. And even for the future, we are going to need these HVDC technology. Now there are this HVDC also, I believe there are two kinds of technology, VSC and VSC provides the benefit that we can use it for black start, which is really ideal for renewable power. Of course, there are experts who will figure out what will be done and where it will be needed. But yes, power electronics is an integral part of the grid today, and we are seeing the benefits with going in for such equipment. And on the load side, yes, our loads are, when you connect more and more power electronics, you go away from the conventional sine wave, which keeps getting distorted, which creates more harmonics. Your transformers do get heated unknowingly. So all those topics are there, and you have to find solutions. Whatever filters are needed or whatever equipment are needed, the engineers in India are amongst the best in the world, and we can definitely find solutions for ourselves. Yes.
Thank you so much, Mr. Vikram. Mr. Venkateshan, what is your outlook on the same?
Yeah. So in fact, I would rather go back in time. So earlier we were 5 regional grids. To some extent, HVDC's role was different because it was 5 regions were operating 5 different frequencies. We required that HVDC plus the control. We had few back-to-back stations. Even now we have. And we have certain culture, which is a dedicated one, exporting the generation. But over a period of time, now we are post, I believe, December 2020, now we are integrated across the country. So all the regions, we are connected with AC lines. Along with parallelly, we have this DC lines. Now the role is no more like I export from one region to another. It's more like controlling the AC line flows rather than inputting or exporting using those lines. The role of HVDC has changed. That is one point. The other one is, like you saw the power flow also, import and export. We have one rider Pueblo, 6,000 megawatt HVDC, connecting southern region with western region. Where and when the renewable is low in southern region, we generally being very renewable rich and the southern region as such. So during those part of the day, we do export to the western region. So the role also is changing. So we cannot simply put HVDCs wherever we like because of the single grid. As far as the technology is concerned, BSC based technology, we have only one place, all are LCC based. That is connecting Pugalur to Thrissur, a short distance between Tamil Nadu and Kerala. It gives a bit of advantage like a black start facility we have over there, unlike LCC. So this is what I hope it made sense.
Yes, thank you so much for sharing your views, sir. And we do need to look at efficient ways of grid integration to improve our T&D infrastructure. Moving to Mr. Suresh, how far are we harnessing microgrids for DERs to enhance resilience, enable local energy sharing, and reduce congestion?
I think renewables are going to play an important role. And as mentioned in the earlier discussion and presentations, the whole nature of electricity sector is changing. And as per the government plan, the electricity will play a more and more important role because electrification of the hard to abate industries or hard to abate sectors like transportation, industries, residential to, and a large scale for cooking, etc., are, in a planning stage. Although we do have now about 150, 120 gigawatt of renewables out of 400 gigawatt. But we are going to go, the future expansion is primarily focused on renewables and renewables for hydrogen generation also, because hydrogen is also likely to come out as a multi commodity as a fuel, as chemical reaction agent, etc. So what I can see is there is a need to upgrade the grid in terms of modern smart metering. There is a need to look at demand side management more more focused way, because demand is going to increase from variety of sector, as we have seen, like mobility and other sectors like digitization of all the sectors. So you have more of IT and IoT coming in picture. And from that perspective, what I feel is more important is capacity building of the electric sector as such. Apart from the infrastructure building and efficiency improvement, what is important is the efficiency of, people who are operating it, and the capacity building is important. We are already involved in couple of projects where we are looking at storage, for electrical grid level storage and substation level storage to avoid the isolation or avoid the, power failures or this. So I think capacity building is going to be an important aspect because new technologies are coming, new business models are coming. Earlier, it was only, the power purchase agreement business model. But now we have, recently we had inquiry where they were looking at purely merchant power sale business model and of a renewable energy plant with hydro storage. So the whole, business nature is changing. The grid nature is changing. So for reliability and efficiency, what is important is to have a dynamic response. Maybe we need to do invest more on simulation of grid at various levels, transmission level or distribution level, and improve that capacity of simulation and prediction of the grid performance based on demand side management and based on the generation management.
Thank you so much, Mr. Suresh. Coming back to Mr. Baldev, you have been actively involved in taking initiative and implementing them in RE integrated grid systems. How do you look at the adaptations of microgrids for DERs to improve?
This grid integration of RE has been posing a problem. Maybe if we have microgrids or DERs, they are an issue. And maybe at the local level, if we have smaller systems where maybe they can be on their own and they are not a part of the major grid, it could be sort of some solution also available at their level itself. But major thing is that we cannot have just renewable without the grid strength, or whether it is a small grid or a big grid. The grid strength has to be there, and we have to have future is not only just the simple renewable, it has to be with the battery backup, and it has to be battery in a grid forming mode only. Then only it is going to give the, you can say, performance. And the grid integration again, because it is a variable source, RE. So over a 24-hour period, if we want to use, we have to have this storage. And then only it can be exploited fully. And earlier your question was there regarding the power electronics. I just wanted to add something which Mr. Vikram also said. Today, we have more than 70% of the load as non-linear load. And the major issue is harmonics only. When you have smaller systems, even the smaller grids and all, this is going to be a very big challenge because the impedance of the system is very less. The voltage distortions are very high because of that. And then we have to see that we have the proper mitigation techniques, harmonic mitigation techniques. Earlier, we used to have just 30% maybe was a non-linear, 70% used to be linear. Now it is just the other way around. So this is a much bigger challenge today. The harmonic mitigation techniques have to be there. And there we have both passive as well as active solutions. And when we come to RE solutions, we find in India, we are having just maybe conventional passive solution available. Just a 6% reactor we give, and we solve the problem for just 5th and 7th harmonic mainly, which are definitely the most prominent harmonics available today. But if we look at the other overseas countries, they go much deeper. In fact, we are also having on paper, we have the conditions. There is a 21st harmonic, 23rd harmonic and all. So those also have to be taken care. Maybe we are taking care in the modeling, but in actual practice, it is not happening. So far, I don't think we have anywhere, you can say, harmonic filter provided for a higher harmonic at all. Because that is a much bigger system. Because here we have 5th harmonic is just a LC circuit. We have simple 6% reactor connected across capacitor. There we have to have a LCR circuit. There is a resistance also, which is almost maybe 10 times bigger or costlier than the reactor. And the levels, harmonic levels are though very low, but they exceed the grid code. So if we have to comply, we have to come with that power quality solutions also. It is applicable everywhere, whether it is a microgrid or a big grid. So we have to have those solutions also, and they are going to be a much bigger challenge.
Thank you so much, Mr. Baldev, for adding the point. Mr. Vikram, how are utilities adapting the microgrid, and what are the challenges in monitoring and maintaining them?
I think it should be first answered by a utility, because microgrid, okay, let me try to attempt to answer this. So microgrid is generation and consumption both within a small area, and ideally there are two kinds of off-grid or on-grid microgrid. Yeah, so which is either grid connected, and if it is grid connected, then it means that it is just taking energy when its own generation is less than the demand, which means that grid is only the last, supplier of last recourse. Now, as grids have been designed, they have been kept with a high amount of investment, which means that they should not be the supplier of last recourse, but they should be a supplier of electricity, because they have made the capital investments. So it is a little more complex situation. Ideally, yes, there could be cases when the microgrid has local generation which supplements and helps supports the grid when the grid needs to meet the demand of the larger vendors. But we have yet to see in real practical sense when that will happen. Yeah. So off-grid microgrid business case is very clear. Wherever there is no grid, it makes good sense to provide electricity. While local microgrid, absolutely clear, and the business case also is very lucrative. So that is my view.
Thank you so much, Mr. Vikram, for letting us know your view. Mr. Venkateshan, how are utilities and grid operators utilizing data analytics and AI to optimize grid integration for efficient energy infrastructure?
In terms of the AI tools currently in India, from our company side, we are trying to explore with renewable forecasting. So, in fact, part of the green energy corridor scheme, we also got the renewable energy management center, which I am looking at. So, there also we have a forecasting tool which is based on the artificial intelligence. And in fact, in our in-house also, we are trying to develop for the forecasting, RE forecasting. So, to a limited extent, we have started using. Maybe in future, we are planning to use it for more. Thank you.
Thank you so much. This question is directed to both Mr. Suresh and Mr. Baldev. When we talk of grid integration for T&D systems, policies play a key role. How are the government policies and incentives aiding to the DISCOMs in curbing losses and adding efficiency to transmission and distribution infrastructure?
This grid integration, these policies, they are the major guiding, you can say, source, and they decide the entire, if the policies are on the right track, maybe things work out. And I'm not fully aware of the entire grid infrastructure, how the policies and trends are there, but looking into my area, I find a lot of gaps are there. Like I said earlier also, this renewable integration, which we are also involved, we are giving solutions to these RE developers. The policies are just not fully, you can say, analyzed before they are being implemented. Or in fact, they are like now they are forcing the people, they are pressurizing the people to go for a STATCOM without having any justification or without having any studies for that, or without knowing whether it is going to solve the problem, or rather fully knowing that it is not going to solve the problem. So there are some gaps out there. And regarding other grid infrastructure, the distribution side, I am more aware because we deal with the people who are in the distribution companies only. They are in a very, very bad shape. I don't know whether policies, how they can help them to come out of the situation, because the problems are much deep-rooted. There are inefficiency problems, there are management problems, the financial problems, and they are all in, you can say, losses and debts and all. And I don't know how we are going to have such a bigger, you can say, setup unless we take care of this inefficiency of distribution companies. And the problem is these people, there are failures. There are some failures are there which are maybe conventional and people know the solutions, and it is just because of the maybe relay settings and protections. They have to just do the preventive maintenance and all. So even there we have issues. But certain problems which are not known, as I said, we have now power quality issues today. The distribution transformers are failing in a very, very large number. I heard in one place in maybe Haryana, there were 5 failures in quick succession. And the whatever root cause analysis is done, I don't, because when I talk to them, I don't find they are on the right track even while analyzing the things. The things are, there are no controls, no, we have IEEE 519 regulations which stipulate that the harmonics exported by the consumer should be within limits. Maybe normal consumers, they come under the limit of maybe 8% TDD level has to be maintained. But it is not implemented except maybe in Tamil Nadu. And these people are pumping harmonics into the grid, and all these harmonics are going into the distribution transformers, and they are failing one after the other. Particularly, we have seen the distribution transformers located near to the IT companies where they generate a lot of harmonics. They fail very fast. So there are issues, and maybe I don't know whether how the regulations definitely play a role. The regulation, although now we have the regulations, the CA has come out, CERC has come out, asking not only the consumers but also the RE developers also to maintain harmonics within limits. But unless it is penalized, nobody takes action because they are able to manage the show. Unless they have issues beyond their control, if they are not able to run the system, then only they take action. Otherwise, they will take action only if there is a regulatory provision for that. Now, this is a state subject, utilities particularly. The CERC can give the guidelines only. They cannot impose all across the country. So these individual utilities, they have to have their own, you can say, regulations, and they have to adopt to them. But as I said, except for the Tamil Nadu, no utility has a working system to control the power quality. And power quality is going to be the major issue. It is already a major issue because we have totally non-linear load today, and that has to be attended to. We have to see that we have the system within limits. And the other thing is that we find a lot of accidents, fires taking place in particularly malls, hospitals, and commercial installations, where there are particularly specific types of loads. There are unbalanced conditions are there. There are particular harmonics are there. There are triplet harmonics, third harmonics, which flow through the neutral. The neutral burning out happens everywhere. And they lead to fires also. We see in the industry because they take care of themselves. Industry has strengthened the neutral system. They use 2 cores for the neutral. All other commercial installations, they use just single core, half core rather, 3.5 core cable. So there the neutral is overloaded. It is not strengthened. It fades. It catches fire. Nobody is there to take care of it. And the accidents keep happening. Fires keep on happening. So there have to be regulations to streamline the things. The regulations are not there at many places. They are there at some places, but they are not being taken to the state level. And even if they are taken, maybe sometimes they are not fully implemented properly. So there are a lot of gaps we have.
Thank you so much, sir. Mr. Vikram, there is a question addressed to you in the Q&A box. Could you please answer?
Yeah. So, okay, I will check this messages. Okay. I think it is a tool for modeling of systems. So, Mr. Deshmukh is saying that it is being used for energy optimization. Okay. So, if it is being used, it is being used. I am Nothing more to say.
Thank you so much, Mr. Vikram. Mr. Suresh, I would request you to please make a closing statement for today's session.
Okay, we had a very good, informative workshop, webinar today, and it touched upon various aspects of grid quality and grid efficiency in the context of A, increasing renewable supply, and B, increasing demand side requirements and demand side variability. Both are now becoming variable. We have seen that now the grid operations are becoming more and more dynamic, and it needs more advanced control and advanced informatics system to understand the functioning of grid. And I think the government through CA is already preparing some plans for improving grid quality and improving the planning with new renewables coming in picture. And we hope that the quality of grid, which is so far is very good, and they have been tightening the frequency variation, and that will continue. And with new business models, there will be opportunities for businesses to have a power plant for different purposes. And I think in days to come, the storage systems, particularly the pump hydro storage, which we have about 100 gigawatt capacity, they will play an important role, because battery storage is a bit expensive right now. But battery storage in the form of short-term storages are likely to play an important role. So I think we see that the electricity sector will emerge as a winner in the days to come with renewable integration and new electricity demand side management techniques. Thank you.
Thank you so much, Mr. Suresh, for the closing statement, and all the panelists for joining us today.
For viewers who have joined us today, we would like your feedback and encourage you to stay connected with us via our social media handles. EPR Magazine is now available on Facebook, Twitter, and Instagram. You can also download our app from Google Play and App Store. We also request our viewers to stay tuned for future interactions.